We're now ready to address seasonality by calculating the seasonal factors. And this is kind of the focus of this module really. Here's an example of visitors to a national park that shows seasonality. I simplified the example just to illustrate the concept, and I'll walk through an Excel set with a much realistic example later based on the real data. In this example, you see visitors to national park in thousands. The data comes from year 2011, 2012, and 2013. And you see that there are 4 seasons of the year, and the data is compartmentalized in those 4 seasons, right? Fall, winter, spring, and summer. And we have the data for 2012 fall, 2013 fall, 2012 winter, and so forth. You'll clearly see that the number of visitors every year in winter is much lower than the number of visitors in summer. And just looking at the chart below, you can see that the data shows some seasonality. It goes up and down in a regular fashion, right? It goes down, up, down, up, down, up in a regular fashion. How do we predict data based on seasonality effects? Now, that's the next step, and a very important step, and something it's very important when you study operational analytics. Let's look at how to forecast seasonal series. The people call this seasonal series because there is seasonality. Seasonality corresponds to some pattern in the data that repeats itself at regular intervals. We can forecast using something called multiplicative seasonal factors. Okay? Multiplicative seasonal factors. I'll use CI to represent the multiplicative seasonal factors, right? I'll like CI, and that could be C1, C2, and all the way through Cn, where I equals to 1 is the first season, I equals to 2 is the second season, and so on. N is the total number of the seasons. If we add all the seasonal factors Ci together, this would give you N, which is the total number of seasons. How do you think about seasonal factors and the data value presented? Right. Suppose somebody tells you Ci equals to 1.25. What does that mean? Ci equals to 1.25 implies that that season is 25% higher than the baseline on average. In the retail industry data, December sales are significant. This means that December sales will have a high seasonality factor in the sales data. Let's look at a method for estimating seasonal factors. The method I'm going to show you has 4 steps. In the first step, step 1, I'm going to calculate the sample mean. I compute the sample mean for the entire data set. We saw how to do this in earlier sessions. In step 2, I calculate seasonal averages. That is, I average the observations for the n like period in the data. Right? N like period. So if it is, I take the average only for one when season equals to 1, and I take the average when season equals to 2, and so forth. And I'll show you while I work through this. For instance, I average all the summers, all the winters data, and so forth. In step 3, I calculate the seasonal factors. That is, I divide the averages that I got from step 2 by the sample mean. Okay? And I get n numbers. The resulting n numbers will add exactly to value n and will correspond to n seasonal factors. It will make sense in a bit. And the final step is what we call deseasonalization. What do I mean by deseasonalization? I have removed seasonality from the data set. It sounds I'm doing things back and forth, but it will make more sense here. All right. To understand these 4 steps better, let's walk through our example and let's look at first step for forecasting. So I have the same data, right? 3 years, and again, we'll do this with more data in Excel, but it's easier to show an example with lesser data. Okay, let's calculate the sample mean. Okay, I calculate the sample mean by taking all the data points and finding their average, and the mean comes out to be 14.33. So this is the average of 16, 7, 12, 23, 15, 6, 12, 25, and so forth. 14.33 is my average. That's my first step. All right. Now, in the second step, I'm going to calculate the season averages. Let's look at our data. How to calculate season averages can be, we just look at each season. So I have 3 years worth of data, I have 4 seasons, right? So for the fall, I can take the average. My fall average is by taking the average of 16, 15, and 14. Average happens to be 15. My winter average is 7, 6, and 6. That is 6.33. All right, so in the rightmost column here, right, this is my second step. These are my seasonal averages, right? Now, third step is to calculate the seasonal factors. This is a crucial step. What do I mean by that? Okay, so the fall season factor is achieved by dividing the fall season average by the whole sample mean. So my fall season average was 15. My sample mean was 14.33. So I divide this 15 by 14.33. I get 1.05. For winter, my average was 6.33. My sample average is 14.33. 6.33 divided by 14.33 is 0.44. It's not going to go, is it? All right. For spring, it's 12 divided by 14.33. For summer, it's 24 divided by 14.33. Okay? All right. Now you can add, the point I was trying to make is, if you add all these seasonal factors, this would add up to be 4. Because we have 4 seasons. This is very important. This is usually for you to check if you did everything right or wrong. The fact that there are 4 seasons means this would add up to be 4. Exactly 4. But let's interpret this. What does it mean to have summer factor of 1.67? What does it mean to have a summer factor of 1.67? Well, what it means is the demand in summer is going to be 1.67 times the baseline demand. On average, the demand in summer is going to be 1.67 times the baseline demand. And that's what makes sense. Our baseline demand is somewhere here, right? 14.33, very close to this 15 line. And on average, the summer demand is 1.67 times your baseline demand. Okay. Now let's do this exercise one more time. The winter has the factor of seasonality factor of 0.44. What it means is, on average, it comes out to be the winter demand is about 0.44 times the average, the total average. All right. Now the next step is deseasonalizing. Okay. How do we do this? How do we generate the how do we deseasonalize the data? All right. To deseasonalize, we have to take away the seasonality from the data set. Does that make sense? The idea is we have to if the season did not exist, how would the data should look like? Let's look at the original data first. 16, 15, 14, 7, 6. The better way to look at it is the 2012 fall happened, the demand happened to be 16, and then winter, we saw this winter, we saw 12, and the data flows this path, right? The data flows that path. Now, how do we deseasonalize the data is, because the fall has a seasonality of 1.05 as we calculated earlier, we divide the fall values by 1.05. The winter has a seasonality of 0.44, so we divide the winter values by 0.44. The spring has a value of 0.84, that's why we divide the spring values by 0.84. Summer has the seasonality factor of 1.67, and we divide that by 1.67. This is what we get. So by deseasonalizing the data, our number looks like 2012. So again, remember the data flows this way. This is the timeline of this data. If there was no seasonality, 2012 fall data would have been 15.24, winter would have been 15.91, or another way, so the equivalent is 15.24, 15.91, and so forth. I went ahead and plotted this data. This you see, the seasonal data and then deseasonalized data. You see, the idea of deseasonalizing is take away these peaks and troughs from the data and make it the data that we were used to before, like the stationary data. After this, you can do any kind of, and you can use any kind of forecasting method, like moving average or normal regression, or any kind of forecast method to this data set that you created, and you predict for a next data point here, right? Suppose you found for the summer, and if this next data point is a fall, then you use that false seasonality factor to change your prediction to the actual thing you're going to see, the real prediction, if you will. Let me repeat that. So what we did is we took the seasonal data, this gray line, right? This gray line. We converted that into this stationary data set. Our real goal is to predict this next value, right? Suppose this next value, after if this value is summer, the next value is going to be the fall. If you're going to using your prediction method, you would find this point, right? The equivalent deseasonalized value. If you know this is a fall, you multiply this prediction value with your seasonality factor for the fall, and you get a new prediction. Let me show this. Let me show this example by looking at a data Excel file that is the data is from Bureau of Transportation Services. It gives you the load factors for the top 100 US domestic market. The load factor means number of passengers on a plane divided by the available seats on the plane, and usually expressed as a percentage. A load factor of 80% means 80% of the seats on the airline are filled. The monthly load factor data that you will see that you see on the file goes from 2003 to 2013, and they show that the trend and seasonality both. You can see that airlines are getting crowded, more and more crowded over the years. You can also see that some months are more crowded than the others. Using the template that I follow, the same previous steps that I showed you to generate the deseasonalized data. You can see the Excel video that I'll make in a bit and post it. All the 4 steps are represented in the solution file. Right? I hope you find the Excel sheets useful and follow along the steps I'll do in Excel, and you can take the seasonal data, create the deseasonalized series, use whatever forecast method you want to use, just like treating it like a stationary series, and go back to this content of to come up with the forecast method if you need to, and then when you have a forecast, then seasonalize the value again. It sounds, I think I'm making it more difficult than it is. You can, I hope you follow along with the Excel.